Okay, so I am very happy and fortunate to introduce one of the eminent distinguished scientist. Okay, and he is also part of our department. You should be very fortunate. We are having good eminent industry expert in ECE department. So Kumar sir also mentioned now, and Chattopadhyay are also one of the distinguished faculty member of our department. He worked for DRDO more than 32 years. Presently, sir is working as adjunct professor of ECE department. Okay, so already sir is outstanding scientist and director DRDO and retired in 2016. He has already, you know, when sir is reaching to that stage, he handled lot of projects. Okay, all of you are aware what is Agni system, all those things. Okay, sir will tell about the importance of learning. Sir also completed his PhD from computer science from Jadavpur University. That is also one of the good university, all of you are aware. So it's an honor to me to introduce Chattopadhyay sir. Actually, sir is mentoring lot of students in the institute. He is taking lot of classes, mentoring even faculty in the ECE department. Okay, he is having lot of core knowledge and robotics, drones, not only that one in IoT. So I request sir to deliver the talk.
You cannot go. Okay. Okay. What is that? What is the slide changing? Oh. Okay. This works. Okay. So, good afternoon. And I must be thankful to Padmasai Madam to give me an opportunity to talk in this particular conference. I am also thankful to the VNR BJIT management and IEEE for giving me opportunity over here. So I think it's late in evening, and earlier people joined after lunch, and still some of them are continuing. Maybe some will be dozing. I think some tea break and other things should have rejuvenated them. Okay, I think because of the paucity of time, you have to bear it with me for some times, because I have got some numbers of slides rather to put forward to you. And I would like to bring a technology. Probably many of you have heard of it, and eventually you are doing of it. That is of digital twin. You know all what is a twin, no? One is copy of others, isn't it? Can you think of a twin of a physical system in a virtual platform? Like we are sitting in this particular auditorium, and we are sitting in a manner at different positions. Can I represent it virtually? And can I monitor it from a place? Yes, we can do. And that is what is a digital twin, where you virtually represent a physical entity and then connect them. See what happens? What is the difference? You do a simulation, MATLAB simulation you have done. All of you have done some simulation, but that becomes a standalone, okay? You represent a machine, but that is a standalone mode. But if I connect it through IoT and other kind of things, then I can infer a lot of real life data, right? And then thereby I can do many things, like many of you may be knowing these car manufacturers who are there. They create a digital twin, and each and every car which is running can be monitored by that, and then they can predict what kind of problem it will be. So that's a different background. I will not go to the car background because my background is different. So I choose a subject on aerospace vehicle. So next couple of minutes, I'll try to give you some idea how to frame up a digital twin of aerospace system and how it can benefit us. So that's what I will try to go. And then, because many of you will not be knowing or appreciate what a aerospace system means, so I need some couple of minutes, probably I'll cut short some of them, to introduce what a aerospace system is, and then what is the system life cycle and maintenance. All of you buy a vehicle, you go for maintenance, no? First 3 years, somebody says, first 3 years it is free. First 2 years it is free, something like this. They ask for increase, you give this much commission, you give me. So I will give you another 1 year, 2 years. So maintenance is known to you, right? So there are two maintenance, which is one maintenance primarily is the preventive maintenance. That means whether your car is working or not working, you go mandatory after 1 year. That fellow will phone you if you are not going. That company fellow will phone you. You come. But then, it's mandatory. Your car is running fine, but still you need to do it, no? So then comes predictive maintenance, that really I need maintenance or not. That solves many of the problems which will come, that how a preventive maintenance creates a lot of effort, time and cost. These three factors, effort, time and cost. And then we'll see how digital twin can help in this particular area. Okay? So we'll go to the concept. I'll try to give a small implementation part, one part of the aerospace system, that is a control system. I'll take you little bit of the insight to a control system, so that whatever we discussed in our previous things, that how to know, how to improve your skills, how to attach your knowledge to the industry or wherever. Probably you will get some idea on this, okay? When you learn this particular, because when you simulate an object, you learn much more than by, using that object even, right? So, and then we'll give what are the steps of implementation and challenges. Since my background is different, aerospace system I define in a different way. Don't get frightened. They are all some things which are used in many places. These days people are using everywhere. You see Israel is using something, Iran is using, Iraq is using, US is using, all over the country they are using all these particular things. So I will not go in detail of this. Lot of advancement is there. Just to give you some idea why this type of weapons are used. Okay, some are targeted to some big installation. Some are targeted to another vehicle which is coming. Some are like aircraft, simple aircraft. The aircraft takes some bombs and bombard it somewhere else, right? Even the drone. Actually speaking, drone has become a very, 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 very handy tool now. So most of the people are using drones heavily. You see the Ukraine war and all. So I will not go in depth of it. Just to give you the context of this and the importance of this particular system. They should be highly reliable, isn't it? Today, if we fire something and it doesn't hit, then everybody will laugh at it, and that country will be in big trouble, that nothing works for them. Okay? And maybe you are listening many of the things. Now the war, what is going on, some people what they are doing, whatever there is there in their store, so many 20 years, 30 years back, they are trying to use them and many of them are failing. So that's the context, how to keep the life long. You take the carry forward is how to give a longer life, how to give reliability. So that's what carry forward, so that it helps me when I build up the things, why a digital twin is required, right? So, and they are fired from different platforms. Platform can be a silo that is underground, that can be under the sea, that can be surface of the sea, it can be a drill, it can be on road. So these are all the components which makes it, kind of things which is a setup. There are little classification, I will not go in depth of it. Most of the things, if I take it, there are certain objects when you take a long range systems. There has to be some range, like I can go from 100 kilometer to 1200 kilometer to 12,000 kilometer, etc. I should get a good accuracy, okay, and I should carry the meaningful things. So that is what is the carry forward. And what it needs is that they are all single shot, so they require high reliability, and they have got lot of state-of-art technology. If you see the technology, what is there in the waterfront, they are totally different. So typically, if we take a rocket or a long-range missile, we will see it is simply a multi-stagers. No, it has got multi-stage. Why I am giving? Because when I take the subject of control, you have to understand why this control system is required, right? So that is why I am indexing all these things to build the concept. So it is going like this and it's turning. How it turns? How it turns? What is the axis of freedom when we take an object in the space? Anybody can tell? Suppose I take an object in the space. What is the axis of freedom it has got? You have all worked with drone, isn't it? What are the different axes? We normally say, no, some axis of freedom, 3 axis, 6 axis, whatever it is. What are they? Anybody worked on drone and all? Nobody? Okay. So, if you know the dynamics, body dynamics, have you read body dynamics? A body, it has got a dynamics, no? If I float a normal object, we are all sitting in 2 axes, 2 degree of freedom, 2 degree plane, no? If I take x and y. Suppose I hang a body, what kind of things it will have? A body can go like this, it can go like this, it can go like this, and it can also do like this, isn't it? Suppose you go anywhere, if I leave an object, what happens? It goes like this. This is called, with this anybody got idea? What is this known as? Have you heard pitch, yaw, roll? No. Okay. So, we have got a 3 axis. If I leave a body 3 axis, what are the 3 axes? X, Y, Z. Good. X, Y, Z. This X, Y, Z is nothing known by, when I put it on the space, normally conventionally we call them pitch, yaw, and axis, roll. Okay. So this is the roll axis, this is the pitch axis, and this is the yaw axis. Okay. These 3 are fundamental. All of you should know about them, and there is a rotation along the axis. Okay. Those rotations are known as Euler angles. Okay. You should know what is Euler angle. Probably you have read all these things. Maybe you are not able to recapture them. Go back and then probably you can study. And so, when I say control, I take a pitch, it is going to the pitch motion, no? It goes through a pitch motion, and then because it is a long range fellow, it has got multiple stages. So it drops out some of the stages, and then it goes here and reach to the target point, destination. When you throw a stone, have you seen when you throw a stone, what happens? The stone goes from one point and reaches to other point. What is that known as? What is that known as? If I take a stone and throw it, projectile, and that projectile, that is a projectile, but the path, what is known as the path? Trajectory, good. So that's what it makes a trajectory over here. Now, you can see if the stone is thrown in a given angle, it can reach up to some distance. If I make the angle different, it can reach. That means if it goes higher height, it can reach to the longer distance. This is what is the fundamentals. And here there are control systems which makes it to follow the trajectory. And there are other sensors. I cannot go in depth of them. Okay, it will take time, but you can understand them. And then I think we'll skip them and go there. So all this particular area, only one thing is appreciation to take home is that these particular systems, there are different type of engineering skill what is required. Whether it is a software engineering or electronics or mechanical, structural, user interface design, instrumentation, aeronautical, all kind of engineering is the subject material of this particular system. Now, looking at the technologies which are required, different technologies, because when you are talking about maintenance, you should know about the technology which are involved in a particular system. So, you have got a propulsion system. All of you know what is propulsion? Propulsion. What is propulsion? How the object moves up. Huh? You have fired Diwali crackers. What is there inside that? What is there inside that? In a Diwali crackers, what is there inside? What makes it to move up? Some chemicals will be there, na? Isn't it? Some chemicals will be there or not? So that chemicals are nothing but propulsion. Okay. Then it has got a aerodynamic structure. It has got a structure like your bike. Bike is there. Bike has got a structure. No, different bike has got different shape so that it can go faster. You have seen the cars which are for the race and the car which is used for the passenger. Have you seen the difference? What is the shape of that? Why that shape is like that? Have you asked question? Why a sports car shape is different from comparing to a passenger car? Okay? Ask these questions so that you can understand why their shape is important. Okay? Some of the bike shape they make like a tiger. Have you seen? Some bikes are like a tiger so that it can jump and go and it can get higher speed. So these are the things which are there part of it. And then you have got power source, you have got control systems, you have got different systems which are part of it to make it to go from one point to other point. And objective is to get a lower mass and longer range, higher accuracy, lethality, and also low cost, high volume and fast delivery. Means you have to make numbers, okay, and is in operation. So this is a typical system I have just taken from internet because I cannot share any information over here. These are all available in internet, so nobody can question me where from you got all this. So they are all from internet. You can also view, you give Minuteman, you will get this particular fellow, okay. So you can see here, just spend little time, it has got multiple stages. These are all different stages. This stage, this stage, this stage. And this is the final item which will go to the particular destination. So during the flight path, they all get dropped one by one, they will get dropped. You can see here, there is a system. This is a control system. You know, I'll take the example of a cracker. Some of you might have seen that fellow, you put it in a bottle. Have you ever done? Anybody has done? A rocket, cracker rocket you have seen? You put it in a bottle and make it angle. Have you ever done? For fun. You have done it, no? And that fellow goes somewhere. You all ho and you all shout, isn't it? What does it do? You are giving it an angle so that it goes there. And how you are giving that angle? You are tilting that bottle. You have put it in a bottle, you are firing it. You understand, no? What I am saying? You have done, most of you must be doing. So then it goes in a different angle and go. Now think automatically somebody does that angle change. Okay? Automatically when device is flying, I change that angle. Then what will happen? It will go like this, like this, like this. There are some crackers which does like this also. You might have noticed some of the crackers are there, they will go like this, like this, like this. They will go in a path, snake path. In a snake path also they go. So that is what is a typical control system which will do this particular activity. Now comes, this is what we talked about system, right? We talked about the system, what a system has to be built, it has got multiple sections, this, that. Now comes, to make a system, what are the different phases? Suppose I want to make a project, What I require to do? I require to first plan it. These are the objectives, these are the things which are there, I have to plan it, I have to analyze it, I have to design, and then I have to develop, and then I have to integrate, implement, and then further life is maintenance. So further life is maintenance. Most of the things which are running, their life will be in maintenance. What is maintenance? When the system is complete and deployed, the system is operational, isn't it? When we say a system is operational, when the system is completely made and it is deployed, that is operational. The work on a operational system is called maintenance, okay? The work which has to be done on the operational system is maintenance. Is it possible to build the right system? Can you make a system which doesn't require maintenance? Can anybody do that? Any system, whether it is in this room, can I make a chair, simple chair which doesn't require any maintenance? Somebody has to clean it, okay? So, that means whatever effort is required, development effort of making a system may be 20%, but maintenance is 80%. Maintenance becomes 80%. So, what are the different types of maintenance? One is corrective maintenance, like your bike, some problem has happened, you go and get it corrected, that is corrective. Adaptive is, suppose there are certain changes have happened because of some fault, you change the other part of it. Then perfective means it is working, but you want something different out of it, that is perfective. But then maximum is preventive, as I told you. Preventive means every 1 year, every 6 months, you will do a maintenance, right? And predictive means there is no time-bound maintenance. It will tell you, now you maintain, now you have to change this part. Within 1 day or within 1 week, if you don't change this part, your vehicle will go down. So that is what is the predictive maintenance. I hope you have understood what is preventive and what is predictive. And useful life can be, how can we improve the useful life? Useful life can be improved by preventive and corrective maintenance, right? If I do maintenance well, I can do a useful life can be increased. So, a maintenance has got time because lot of activities you have to do, you have to test it, you have to address the failure, etc. I think most of the people are going now. So, you have to spend little time to understand any of the concept, okay? So, what the message is, for doing maintenance, you require to put some effort. So, different effort which we take, as far as the preventive maintenance is concerned, it is around 50% of the life cycle. And when we do a preventive maintenance, it has got a cost involved, okay? And it has got a manpower. So, another thing is the negativity. Nobody likes to do the maintenance work. If you ask somebody, they can do a good design, but nobody likes to do any kind of maintenance work. And generally the salary also will be very low, right? Because everybody will say that it is a different type of work. So, these are the negativity which comes into the factor of maintenance, whereas that is very important. 80% of the things we are spending on maintenance. A equipment today I build, it should run 20 years. So you see the phase, 20 years it has to run, suppose, 15 years it has to run. So that's the kind of thing. So, whereas nobody likes to maintain, so many times you will find your systems are bogged down, you are just buying another one. So, So I hope you have understood what is preventive maintenance and what is predictive maintenance. So now I'll just directly come to the digital twin to say that how digital twin can help in doing the predictive maintenance. As I told you, a digital twin is a virtual representation of an object or a system designed to reflect a physical object accurately. Okay? So I have got a, say I have got a fleet in this particular one. So that fleet I can, represent digitally. Digitally how? Because you can use Fusion 360 or CAD/CAM software. You can put a model out of this system straightaway, and then you can get its operational history, its maintenance history, its real-time operational data, and also its failure history. And then you can make a model, and you can model in two parts. One is the whole physical system, you make a CAD model, and then what is there inside to that? That modeling you have to do with some kind of tools like MATLAB or Simulink, like a vehicle is moving, so that we do it. And then when I interconnect them, you interconnect them with the IoT kind of things, no? The sensor which is there in that system, that has to transfer the data to this, and then you have to use the machine learning technique. So those are the components which will come as a digital twin. So it is also like a infrastructure. Suppose I have a large infrastructure. All these infrastructure, they call for big maintenance. So lot amount of maintenance it will be required. But if I can simulate them virtually at a particular platform, then I can know where is the problem of that system. I can predict also the problem of the particular system. Now, what are the key components of a digital twin? What are the key components are? Number one, you should have a physical asset. Also, you will have a virtual asset, right? And then in between, you will have a sensor data, that is from the physical system to the virtual system. And then you will have a data analytics tool where you capture the statistical data and the real life data, and then you should have a predictive model, which can predict the faults. That means whatever failure history is there, that failure history is available with you. Also real time you are calculating getting the performance of the system. With all these two things, you can make a predictive model, and then that predictive model can go for the maintenance requirement. Okay? Prediction model will tell you now this particular maintenance is required, or these parts you have to change something. So thereby you see you are reducing your maintenance time of preventive maintenance and also the manpower, and also you will get the people who will be interested to do this job. Earlier case people are not interested because here now you have a different technology. So once you give a technology, then people interest will grow in that direction. So what are the things we require to build? One is you require some CAD/CAM software or simulation software like MATLAB, Simulink or Python. Then you require Internet of Things and cloud computing. Also you require statistical analysis or the machine learning analysis. So these are the, in nutshell, components. So, and that's a particular thing just we have shown how a physical system will look like in a digital domain. That means if I have got a rocket and that rocket I want to represent in the virtual world, this looks like this. So benefits and challenges. What are the benefits we get from the digital twin? We get enhanced safety. We also get increased operational efficiency, and of course we reduce the maintenance cost, and also we can improve the asset performance because we are telling in advance. We can reduce the cost also, and we can also enhance the safety, because if some system fails inadvertently, then it may be a safety hazard. So if we have a digital twin, it can notify you, and then you can probably take a immediate action. Thereby you can save yourself also. But what are the challenges? You require good amount of data, and data quality should be good, and you require good amount of computational resources, because when you play with all these modeling techniques and other kind of things, you require a very high degree of computational power, and then you require a lot of model complexity will be very high, and you need to integrate with the physical system. Not always you can integrate with a physical system. Suppose I have a car, I don't want to share my data, then I am blocked, okay? Or especially all the defense systems and all, data sharing has got a big problem. So you get a problem over there. And then what it can do, it can accelerate the innovation to test a new design, material and operation strategy. Because this particular system is a learning, and it can also give you the data for the future systems. So I have just taken a model of this particular one. It is also available in internet. On a rocket, you have got a control system over here. This is a electromagnetic actuator. This makes it to move left or pitch and yaw direction, so that it can maneuver. That's the thing is there. Now, what we need to do is a tool to be manufactured to find a state of the system in real time. Okay, in real time, I should know what state it is. So it's a combination of IoT, ML, and modeling and simulation. And these are the design parameters what we spell out. Everything will have a design parameter. So you need to spell out what are the design parameters are required. And then you need to draw a block diagram, simple block diagram, that how the system function. So this is a typical PID systems, okay, proportional integration and differential controller. So those who are having a control background, they will be able to understand. That is, it's a feedback control. So from the controller, you get sense the output, and then give it to the controller and make it to move as required, right? That's a simple language, that's the controller, and it has got so many measurable parameters, okay? It has got some measurable parameters. Those are the measurable parameters are the index of that particular system, how the system is behaving, or at a given input, how the reaction is coming, what are the outputs are coming, they are the measurable parameters. And then any plant when you make, you have to model it, means you have to make a transfer function of that, right? So any control system, when we make it, we create a transfer function. Transfer function is nothing but the output versus input, the relation what you get, that relation you establish in a mathematical model. And if I give an input to this transfer function, I get my output. You can see here the inputs whatever is given, and you have got the output in the blue color. Intentionally this blue color, some of the things you see some kind of jittering. That means there is a system performance, there is a issue in the system performance. So with that, you should be able to infer what is the problem of that particular system. Otherwise, it should be a smooth curve, but the smooth curve is not coming over here. It is given intentionally to understand how you can infer a fault or a failure, right? And these are the components which a particular system has got, because you should understand the components of that system so that you can build your particular model. Then you have to do a FMCA or failure criticality analysis, and you have to find out what are the different types of faults can be there in a particular system. Like it can be a sensor fault, or a mechanical fault, or a electrical fault, or it can be a software fault. No? These are the different categories of failure. So different categories of failure, you need to model it, then only your system will work. So these are the background work what you need to do. So typically I have shown you again a virtual model and a physical model. So this is a physical model, okay, where this is the physical system which is there, and these are the input output relation. In virtually also, when I put it in the virtual map, same profile I will get over here, okay, and in between I have connected through the IoT, right? In between we have connected through the internet, so that whatever data is captured over there, that data is passed on. Suppose there are thousands of cars which are running today on the road. So each car, if I have to get the data, and each car I have to see what is their behavior, what kind of things is happening over there, so that I can do a zero maintenance. So this digital twin will help me to do such kind of activity. So this is what is the sequence, how to build a digital twin. So first of all, make a CAD/CAM model, and then you make a simulation model, attach them, then obtain the data, and then pre-process the training data, develop a predictive model, and then deploy the algorithm. Okay. So these are the different steps, and how it is done. You do the sensor data like vibration, temperature, current, voltage. These data are also the environmental related data. Like suppose the vehicle has got some problem, we will hear the sound, and then we can make out there is some issue in this particular vehicle. That same sound you capture, or there is a vibration, or the temperature is little high. So these are the parameters which will come. Then you have got historical data. Historical data is a particular system has got its own performance, and those performance data will be available with you. They are based on the statistical data, also real life data. And then you do this data cleaning, because you get a lot of different type of noisy data. As morning somebody was trying to explain, if there is a noise, the x becomes y, y becomes x. So that kind of thing. So you require the cleaning of the data. Then you do a feature extraction, because whenever we want to map particular area, so I should know the feature of that particular one. So how in terms of mathematics, when you go, it will be mean, standard deviation, or cutoffs, etc. And then you will have in the frequency domain, there are frequency domain and time domain. These are all features you require to extract. And then there are some specific monitoring for the control system alone, is the vibration analysis, current signature, temperature monitoring, and sensor fusion. These are the parameters which we should get. Then we apply, with this data, we apply the machine learning techniques. Okay. So we have already seen that there are supervised and unsupervised techniques. Supervised techniques are to get a faulty or normal state, how it behaves. That means I can level these particular things, whatever feature I extracted, I can level them, and then I can create a match to that particular level, and then that can be a supervised learning. Unsupervised is different other anomaly detections which are not possible to level. All the data will not be possible to level. In such case, we will go for the unsupervised learning, and then you go for deep learning for further, that is the time series data. You can also go for the CNN and RNN algorithm. So these are the techniques what we will follow to predict even the failures which are not visible to a human operator. Okay. And then you need to do model evaluation. So evaluate a model performance, like its accuracy, its precision, recall, and F1 score. These are those who have gone through the machine learning techniques. You have got a false positive, false negative, and then true positive, true negative. From there you can find the accuracy, precision, recall, and F1 force. So these are the parameters which you should make, and then you evaluate a particular model. And also you do a cross validation by segregating the training data and the test data. Okay. And then there are certain hyperparameter. That means, like if you go to a CNN kind of things, there are a lot of hidden layer. So it has got something at the front and something at the end, but in between there are so many hidden layers. Those parameters, like those weights and other things, you need to vary. So those parameters you need to tune them. So then comes what is the deployment and monitoring. After this, when the model is ready, then you go for deployment and monitoring. That is real time implementation. Deploy the model in real time, and monitor the system health continuously. That is, health is the best parameter to measure in any system, no? Normally in a human body also, if you want to predict any kind of problem, health problem, you always try to monitor in a normal condition what is the health status, and you can see the variation of that, and thereby you can generate lot of data. And then continuous learning is update the model with new data to improve the accuracy over time, okay? And alert the system, that is, you make a notification system by which it can alert about the potential faults. So what are the challenges and considerations of this to make this? One is, as I earlier told, data quality. Ensure data quality to avoid a biased model, right? You should have a good data analysis or data filtering. Leveling complexity. In this particular case, like any, if you say image, because we know about it, like a cat or dog or something like that, we can easily level it because they are all known. But in case of a fault of this type of systems, it's not much known to us, okay? So those complexity will be there for leveling. Computational cost will be very high, definitely, for doing the deep learning models and all. And real-time constraint like data latency, etc., that you have to see when you are transferring the data from the physical system to the real-time system. There are a lot of latency issues will be there. You also require domain expertise, like why I picked up this topic, because I have a knowledge on this particular area. So I can easily speak about it. So I have picked up this area. So that means you cannot just like that make a digital twin for something until unless you know about it. So you require to acquire the knowledge. So you have to have a domain expertise. And then I think with this I summarize that we tried to discuss about the operational requirement of any aerospace system, why these aerospace systems are very critical, and then why maintenance is important for this system to increase the length of life of this system. We have also discussed difference between a predictive maintenance and preventive maintenance, and then we have seen that predictive maintenance can reduce the time, cost and manpower requirements. We tried to explain about digital twin concepts, discussed implementation, how to implement. In nutshell, I tried to explain you how can I do it, but always it is like it was discussed earlier session also, that until unless you put your head onto it, it will be very difficult to understand the concept. So you take a very simple object and try to make its virtual entity. You take a small chair or table or whatever you find which is very handy for you, or if you have made a simple toy car or a toy robot, you can take that also as a model, and then you see how I can incorporate as these particular things. So we also have discussed some of the challenges and future work which is there in terms of data quality, connectivity and modeling, etc. With this I complete the things. I think I thank all of you. If nobody is there, probably if one or two questions I would have been happy, but I don't find any stuff to be there. Okay. Anybody has got any questions about how to make a digital twin? You should be interested how to make a digital twin of a human. Can we do? Can we create our replica? I need not come over here and I need not show online. Virtually you can see me from my place, okay? Anyway. Okay.